video will talk about the last portion. Okay, other scenarios of pressure question that I briefly discussed which are useful. Okay, actually I didn't tell you that I'm gonna talk about this, but yeah. After that, then I'll talk about the whole summary of this whole lesson too, and then I think this will be very fast. So let's start now. So there's three scenario only. So 2 and 3 are those that I don't know what the hell is this, but let's talk about 1 first. So this is the fluid 1, H1, and fluid 2, height 2, and fluid 3, height 3. So imagine height 1, height 2, height 3, they are the same, okay? So perhaps they are not the same, but let me talk finish first. Okay, anyway. So you know that pH is equals to P absolute minus P atmospheric, right? Absolute, yeah, I think you know. And then I'll just bring atmospheric over here. It will be Pg plus, because we bring over here ATM. So now Pg in this case, this Pg is this one. Is the gauge pressure of what we're gonna find, which is this one, okay, which is this is the thing that I'm gonna talk about. So you will be tempted to actually do the wrong method, which is this one, okay, where rho 1 H1 plus rho 2 H2, where now you are taking the height for this, okay. You thought that this is H2, okay, but this is not H2, this is H2, okay. What I mean is that when you're taking the pressure, because you want to sum up all the pressure, right? You want to find the pressure gauge for a whole system, okay, because they have different property, okay. The gamma for this is gamma 1, this one is gamma 2, this one is gamma 3, so you cannot solve them equally. One method is either you solve them, you get their gamma, you get their specific gravity, you add them up together, you divide it by how many portion they are, and then you multiply by their height, provided their height are the same, meaning H1, H2, and H3 are the same. Otherwise, you cannot use this method. Okay. So maybe let me rephrase my words so that you can. Yeah. So in order to solve this thing, you may be tempted that okay, dude, I'm gonna solve using gamma 1, okay, fluid 1, multiplied by H1 plus gamma 2 H1 plus H2. Okay, you may be tempted to do this, but this is the wrong method. Okay, this is the wrong method. Don't do this thing. Okay, because the pressure will be very high. The reason why you cannot do this one is because it's because you're thinking that this whole portion here is fluid 2. Okay, when you're using this formula, you're saying that this whole portion is fluid 2, okay, which is no, because this whole portion, the first portion is fluid 1, okay, and then the second portion is fluid 2, okay, so you cannot use this equation anymore, right? So this is a very powerful, it seems to be easy but rather than very tricky question, so you have to be very careful. So this whole method is wrong. The reason why is because, let's compare with the right one first. Okay, the correct method is doing this. If gamma 1, the fluid specific gravity of the fluid 1 is 2, and then if it's for fluid 2 is 3, and then for fluid 3 is 4, meaning gamma 1 is equals to 2, gamma 2 is equals to 3, gamma 3 is equals to 4, and then H1 is equals to 3, this is equals to 3. We are just simply multiplying this portion, and then add up with this portion and add with this portion. So you are summing up all the partition. Okay, you get the P gauge equals to 27. Now, to check whether am I correct, I'll just, because since they are proportional, their height, okay, the amount of fluid 1, 2, and 3 inside this container are equivalent, okay, meaning how much fluid 1 has, fluid 2 also has, so they are they have the same amount of fluid inside their own partition. So therefore I took 2 plus 3 plus 4 over 3 equals to 9, provided their height is proportional lah, okay. If let's say this one is 4, 5, 6, you cannot use this method anymore. okay, and then you cannot check whether your method is correct or not. But if it's the same height, okay, three as I drawn over here, you can actually check and it's equals to 27. However, if you were to, because since this one is 27, it's never gonna the same to be 16. So therefore, as you can say, this is the previous method, okay, where just now as I said this one, right, and then the plus. Okay, so this whole thing, it's wrong. Okay, it's a wrong method. Don't use this method. Okay, so just to summarize, okay, for this portion only, is that when you are given this formula, I mean given this question, um, take the gamma of the fluid one, multiply by the H1 only, and then you add up, and then you plus gamma 2 times H2 plus gamma 3 plus H3, which is this one. Okay, so use this formula. So this is my my summary lah. Okay, and then scenario 2 is this one. If you happen to see these two shapes, okay, just let me know. For scenario 2, you can use this equation. Okay, this is the pressure difference. Okay, this is the pressure gauge. This one is the P absolute, and then P ATM is equals to 0. Okay, so for scenario 3, I think it's a very similar question to this one. Okay, if you were to solve this, you eventually get the answer. I mean the equation. So this is actually I've actually got the answer. Okay, but maybe in the future then I'll just do this question. But yeah. So so lastly, I want to summarize whatever thing that I've known. So for very first part of this lesson, we talk about the pressure variation. We got the body force and surface force. When pressure variation, when our fluid is at rest, when the fluid is at rest, and then you can derive the formula for specific weight formula, which is the rho g equals to specific weight. And then we use this understanding to derive compressible and incompressible fluid their formula. So we have the pressure head formula. Okay, this one. Okay, we derive this thing. And then we also derive the exponential one for compressible. So previously this one is incompressible. This one is compressible. So we derive formulas for each of this case. And then we also um, understand the equation for P gauge equals to P absolute minus P atmospheric. And this portion are the tools, okay, these are the toolkit for us to derive equations for this, okay, measurement techniques, okay, to derive equations to solve for the general equation to describe the pressure gauge difference, okay. And then in order to solve these things, we actually uses this step-by-step basis. You find a point of fluid, you make a relationship with this point, and then you try to get whatever point that is in the diagram, okay, whatever points that is in the diagram, you try to link them up, and then you create an equation that is equivalent to this form, okay, or this form, and then you solve for a P gauge, and so therefore I hope that I've made everything clear. And nonetheless, if you are to given an equation, I mean a question like some question where your gamma and your everything is given, okay, let's say I haven't done this yet, so maybe you're given with all the specific rate and stuff. You have to derive a general equation first in order to solve it. Don't straight away jump into and solve it, I think. So maybe in the future I do a tutorial, then I'll just do an example to show you. Well, all in all, I set you down with this thing. Okay, and then lastly is about the fluid, this scenario one, a very important concept we need to understand. And then for these two, I'll leave you to find out. And then I'll just set it off, and we are off to lesson 3, and see you there.